Good morning. My name is Juhani Siro. I'm the account executive for ATR, and I'll be hosting this webinar today. With me, I have two professionals, Sami Kulmala and Juuso Pyykkönen here today. Would you like to say a few words about yourself to the audience, please?
Hi, I'm Sami. I'm the CTO of ATR Soft, and I will be looking at today's topic from a strategic point of view.
Hi, I'm Juuso. I'm a full stack developer, and I've been mostly focusing on data and AI driven projects.
So nice to have you here both. Now, one question our industrial customers ask more and more is that when does it make sense to run AI on your own hard drive instead of in the cloud? And that brings us to our topic of today, local language models. Now, that's a huge topic. So our approach is to break it into three teams. And in the first part, we're going to explore what local language models actually are. Then second, we'll take a look at the model landscape and the model families. And lastly, third, we give an overview of the practical side, what they cost, and what are the concrete industrial use cases. So let's kick off this webinar explaining to our watchers, what do we mean by local language model?
Well, a local language model lives on your hardware. Mm-hmm. It can be your workstation, your laptop, on-prem servers, factory floor machines, and all the data waits also live with you. So all the processing happens on your hardware. And all the data stays in your network unless you decide it shouldn't. Whereas with these cloud models, you are sending your prompt to someone else's server, and then they process your request and give the answer back to you. That's convenient service, but you are exposing your data.
Mm. And these local models, are we talking about the same kind of thing as the cloud service models, but just smaller?
Yeah, the underlying technology is the same, and even though usually the local and open models are much smaller, we still call them large language models. And they do the same things like summarize, answer questions, can do some coding. But they still have some limitations, of course, compared to the huge flagship models that you run on the cloud.
Mm. So why do you think that the industrial companies are looking at these right now?
The biggest reason we hear is data sovereignty. Companies do not want to send their intellectual property or secrets or that kind of stuff to any third parties.
And then there's the intellectual property point of view and different regulatories. Depending on the industry of your organization, there will be jurisdictions. You have different obligations where you should be processing and hosting your data. Local model simplifies that quite a bit because the data simply doesn't leave the building.
Yeah, and then there's the pricing unpredictable. The pricing might be unpredictable. It can change any time, and it's even expected to change. And if you depend on a certain model, it can be deprecated. And if your system is really dependent on it, well, you're screwed. Or at least you have to change the model. The local models, once you have downloaded it and you run it, it will stay the same forever, basically.
And security is another one I put high on the list, because when you send a prompt to a cloud provider, You will be trusting their access controls, their employees, their sub-processors, their incident response, and that's reasonable for some data, but not all. And with local model, the attack surface is much smaller, and that is something you have already covered for stuff you have on the network either way. And there will be no new dependencies or no new places your data will be sitting in, or no new vendor breach exposures. So for many organizations, the security point of view is the single thing that decides the conversation.
Well, yeah, that makes sense. What about the offline use?
For industrial sites, this is really about the requirements of the critical processes rather than the network reliability itself. If a process can't tolerate the dependency on something that is outside of your control, let's say external service provider availability, network routing issues, the architecture has to reflect that. So local inference removes that external dependency altogether, and local model keeps working on your terms, regardless what is happening elsewhere.
Is this something completely new, or has this been possibly able to do this for a long time, or and people just didn't notice it, or how is it?
The smaller local models have gotten a lot better maybe in the last 18 months. So before that, they were kind of toys, and just you could do something but not really comparable at all to the bigger cloud models. But now there's been, of course, the cloud models, flagship models have gotten better, and the small models too, because they're kind of the same version of them but just smaller. And now you can run them on consumer hardware, so that's a big thing. And there has been even talk of some programmers changing from the cloud models to only using local models because they're getting so good that for this like special case of programming, you might not even need the flagship models anymore. And there's local models like Qwen, which is maybe the most popular right now, Gemma, DeepSeek, and Mistral models that are quite popular right now.
Oh, that's pretty impressive. Now that you mentioned those model families, it gives us a smooth transition to our second theme. So let's look at the landscape next, what's out there and what people should know when they start comparing the models. So Juuso, could you please continue and give us an overview of these model families, please?
Yeah, so Meta's Llama models used to be the hot open models to run locally, but now there's really many new players in town, like Alibaba, which has released the Qwen models, DeepSeek, which also publishes a lot of research on the topics like optimization and such, and Google's Gemma, the European Mistral, and even NVIDIA has started to publish some models. Many of the open models, the smaller ones at least, are specialized for something. Some of them might only work on text, and some of them might be able to caption images or handle video and that kind of stuff. So when you're picking a local model, you should focus on picking the right tool for the job instead of just picking the most popular or the best model.
All right. Well, that's a very good coverage. Thank you. So let's talk about size now. what does this mean if we hear like 8B or 70B, and like what's actually possible on different hardware?
The B stands for billions of parameters. So 8B is 8 billion parameter model, and usually more parameters is better, and there are some usual type size classes like 3, 8, 30 and 70 and so on. I mean 3, 8, 30, 70 billion parameter models.
Okay.
Those are the usual sizes. So 3 billion might be runnable on a laptop. 8 billion models need some mid-tier consumer hardware. 30 billion parameters is maybe the best bang for your buck. You need some higher end consumer hardware, but those models can do the things that the flagship models can too, at least at some capability.
Yeah.
Bigger than that, like 70 plus, they need some serious hardware, like server grade hardware, and if you have if you have the hardware, then why not? But I wouldn't recommend it for the first models, at least. There's a lot of people that tinker and optimize the models so they can run bigger models with some optimization on less hardware. But usually there's some trade-offs like speed, accuracy, and of course the hardware requirements. So your use case should determine what you want to optimize for.
Now, the scale you gave is quite big, like from 3 to 120 billion. What do you actually get when you step up in size?
You get extended competence, you get more reliable reasoning, and a small model can be surprisingly good at the thing it has been tuned for, but it will trip and hallucinate over the edge cases. Larger model handles ambiguity much better. It can follow complex instructions more reliably, and it's more forgiving. With well-defined tasks, the small model is often enough, but with open-ended operations, the bigger model pays off.
You mentioned there in the middle tuned for. Could you please elaborate on that a bit?
Yes. Out of the box, these models are generalists. Those have been trained on huge mix of text, and those can do a bit of everything. Then tuning or fine-tuning is something where you take that generalist and specialize it for your own context.
All right, thanks. I'm sure quite a few people online are wondering this next question. How do these local models actually compare to the cloud flagships like GPT and Claude and Gemini?
Yes, these frontier cloud models are of course dominating with the hardest reasoning tasks, long context work, and with capabilities they provide out of the box. If you give this frontier cloud model a messy, vague request, you'll generally get a better answer than from anything that you could run locally. But for many practical tasks or manufacturing operations, the gap actually isn't that big. Fine-tuned small model can even beat frontier cloud model in specific use cases, like production line quality controls, harmonizing inconsistent data on the fly, or giving regulated instructions based on your internal policies.
All right, well, thanks explaining this. It helps me at least. So now we've covered basically what these models are, and now we've covered the landscape, how it looks like. So let's get to the part that our audience is probably waiting the most, the practical side. And let's begin this theme with a little money talk. So, what does it cost to use these local language models?
It really depends on the volume. Cloud AI is brilliant when the usage is light or unpredictable, because you only pay for what you use. Then with the local models, it's quite the opposite. You pay upfront for all the hardware, then the cost of a single request is close to zero. So for a small team with occasional use, the cloud service is almost always a better option. But for an organization with AI in their daily workflows, let's say having hundreds of thousands of interactions per day, it goes the other way around.
Yeah, like Sami said, the cost is very front-loaded. So after you buy the hardware, it's almost zero, only the electricity costs. So to run 30 billion per annum model, you could buy something around 2,000 to 4,000 euros worth of hardware and run it quite comfortably there. If you have a lot of users though, then you might need several of the models running
At the same time.
Yeah.
Well, while we live in a world where everything is recurring revenue, it seems like a bargain. But who should be looking at these models seriously? And also, I want to know, when would a local language model be a wrong choice?
You should consider the local models when you're handling data that shouldn't leave your environment, or you have high volume usage. You need predictable costs, you need stability, or then of course if you have any offline requirements.
Yeah, you could also do a hybrid model, so just use the local models for smaller and easier tasks, and when you need to do something big and complex, then go for the cloud models again.
Will you please give us a few industrial examples where these could be used? Like where do you think these would work the best?
One would be unifying data and building a semantic layer, like translating legacy data and naming conventions, especially when the data is deeply proprietary. Another thing is operational support for production and maintenance, like fault diagnostics, explaining alarms in plain language, or summarizing shift handovers. And then there's documentation, knowledge management. You could do work instruction retrieval with RAG. You can standardize supplier documentation, documented technical stuff, so that all knowledge stays internal but becomes searchable. And then of course quality control. For example, image analysis of production line stages and other sorts of anomaly detection.
All right, thanks. That's very many things you can use it for. So now we've covered quite a bit today, but I'd still like to hear one key takeaway you could leave the audience with. I'll let Sami go first.
Well, local models have crossed the line from experimental to become actually practical. So if this is a topic you have looked before and it seemed like it wasn't ready, I think you should look again.
I'd say just try it out and see if it works for you. There are some tools to set up locally, like Ollama and LM Studio. They're quite user-friendly. Might need some technical knowledge, but just ask a chatbot.
All right, so everybody can go set up their language
Yeah.
model right after this. All right, well, thank you, Sami. Thank you, Juuso. It's been a pleasure to have this discussion with you. And thank you, everyone who joined us today. We also had an opportunity to send questions during the registration, so let's see what people have asked regarding this topic. There's a first question. You have an opportunity to predict the future. What do you think will happen with language models?
I think local language models will become more and more common, mainly driven by the costs and information security, but of course by all the other factors that we have talked about here today.
Yeah, I also think the costs of the cloud models will go up. When people depend on them and they're getting used to them, then of course then the prices go up. So I think local models will be used more in the future.
Yeah, that sounds reasonable. I mean, people have invested a lot of money in the cloud models, so I
Yeah.
guess they need the return also. There's also another question. What's the biggest risk there if the company considers using local language models?
One would be underestimating the integration work needed with local model setup, and the other one would be then overestimating the capabilities of a local model by trying to solve some big and vague tasks with it.
Yeah, well, with integrations, ATR can help you. So there has also been a possibility to send questions through YouTube, and we'll get back to all those questions in writing afterwards. Now, if you have a need for a local language model in industrial environment, you can get in touch with us through the link we'll share after this session or through our website. Our next ATR webinar takes place in August, so please follow our communication and tune in again after summer. Have a great rest of the day, y'all. Bye-bye for now.